Bismillah ar-Rahman ar-Rahim. In this video, I'm going to talk about L'Hopital rule, how to find the limit of rational function numerator and denominator using L'Hopital rule. If the limit is 0 over 0. See, now example, if you ask to find limit, x approaches 2, and I have here x squared minus 4 over x cubed minus 8 equal to, clear, I have this one is 4, 2 squared, minus 4 is 0, and 2 cube, if I put 2 cube, so it will be 8 minus 8, 0, so it will be 0 over 0. So the limit using L'Hopital will be that equal to the limit here, x approaches to the derivative of numerator 2x over the derivative of denominator is 3x squared. So clear here, I have here x with x, so it will be 2 over 3x. X is 2, so it will be 2 over 6, which is 1 over 3. The answer is 1 over 3. Another example. To find the limit, x approaches 2, and I have here x cubed minus 8 over 2x cubed minus 3x minus 10. Now see, if we replace 2, this will be here 8 minus 8 is 0 over. If you put 2, this will be here 8 by 2, 16. Put 2, 3 by 2, 6, minus 6, 10, minus 10, 0. So also we have 0 over 0. Also 0 over 0. So the limit is equal to limit x approaches to the derivative of numerator is 3 x squared. The derivative of 8 is 0. The derivative of denominator is 6x squared minus 3. The derivative of 10 is 0. Equal to 2 replace 2 will be 3 by 2 squared, which is equal to, this one is a clear 12, and 6x squared, this 4 by 6 is 24, minus 3 is 21. So divide by 3, so it will be 4 over 7. 4 over 7. Another example. If we ask to find the limit, x approaches -1, and I have here 5x squared minus 3x minus 8. Divide by 7x squared minus 4x minus 11. See, if we replace -1, this will be here 5. -3, I have a -1 will be plus 3. So it is 8 minus 8, 0 over. If we put -1, this one will be 7. This one will be, the second one will be plus 4. So there is minus. So 11 minus 11, 0. Again, we have 0 over 0 in this example. So the limit will be the derivative of numerator over the derivative of denominator. So limit x approaches -1, the derivative of numerator, which is 10x minus 3, the derivative of 8 is 0, over the derivative of denominator is 14x minus 4. 14x minus 4. So now replace x -1 will be, the numerator is 10, -1 minus 3, so which is equal to -13 over -1, 4 minus -1 minus 4. So it will be -18, so it will be 13 over 18. Will be 13 over 18. Another example. Let us define the limit. Another example. Limit x approaches 10. And we have here 3x squared minus 3x minus 270. Divide by, I have here 5x squared minus 7x minus 470 or 30 to be 0 for 30. Okay, now if we put 10 here, So this will be 300, and this one is 10 by 330 minus 270, so you have 0 over. If I put here 10, this will be 500 minus 70 will be 430 minus 430 equal to 0. Equal to, so also we have 0 over 0. Also have 0 over 0. Okay. If this one is 0 over 0 equal to the answer, limit x approaches 10, the numerator is 6x minus 3 over the denominator will be 10x minus 7. So equal to the limit x approaches 10, so it will be 6 times 10, which is 60 minus 3, 57. So here I have numerator is 57, and the denominator is 10 times 10 minus 7, which is 93. 93. So really this one, okay, let me return back to this one. This one is 2 by 3 is 6x, and derivative of 3x is a 3, and the derivative of the denominator 10x minus 7. Minus 7. So this one, if we put 10, here we have 60 minus 3 is 57, and put 10, this one is 93. This one can be also simplified, can be divided. This one, if we divide by 3, this one will be 1, and will be 19. And yes, it will be 19 divided by 3. And here, divided by 3 will be 30, 31, equal to 31. It's okay, is the answer. Now, another example. See, the same this example can be changed. For example, let me say limit x approaches 10. For example, I have a 3x squared 300 minus 5x 250. If I put 250, will be 0. And if I say 7x squared, see 700 minus 8x, this is 80, 620. If I put here 620, will be 0. That is me. Now to find this limit, that is me to find this one. This one is a 300. Or this one is 50, so it'll be 250 minus 250, 0 over. This one will be 700 minus 80, 620 minus 600 would be also 0. So then also we have 0 over 0. So then using the L'Hopital rule, the limit is equal to, by the L'Hopital rule, equal to limit x approaches 10, the derivative of numerator. Numerator is 6x minus 5. The derivative of denominator is 14x minus 8. So equal to. This one will be 1060 minus 5 is 55 over put 10 140 minus 852. But this also can be simplified. If we divide by 11, this will be 5 by 11. This is 1, will be 2, 22 will be 2. So it will be 5 over 12. 5 over 12, the answer. Another example. Let us define the limit. X, if you have negative number, like this one, negative 5, for example, negative 5. And there I have 2x squared. See, this will be 50 minus 3x. So it will be plus 15, so it will be 65. So if I put 65 here, it will be 0. The denominator is 3x squared will be 75, and minus 5x will be plus 25. So if I put 100, it will be 0. Equal to, see now, check again. Now to find the limit of this one. See, this one is 50. This is plus 15. 65 minus 65 is 0. And this one 75. This one. And this is a plus 25. Okay, so 75 plus 25, 100 minus 100 is 0. So also 0 over 0. Now again, using L'Hopital rule, the derivative of numerator over the derivative of denominator. So then the limit x approaches negative 5. The derivative of numerator is 4x minus 3 over the derivative of denominator is 6x minus 5. Now replace negative 5 would be negative 20. This one before by negative 5, negative 20 minus 3, negative 23. And if I put negative 5 denominator, negative 30 minus 5 is 5. So would be minus 35. That is mean is equal to 23 over 35. The answer, the final answer, over 35. Another example. Now, if we have sometimes you have root, like for example, you find the limit x, okay, you find the limit x approaches, let us say 1, and for example, I have this one, 6x squared, okay, 6x squared minus this one, let us say 6 radical x. This will be 0 because x1 I said. And over the limit of, let us say this one, x squared minus 1. So this one is also 0. So if we replace 1, see, if we replace 1, this will be here 6, and replace 1, this also 6 will be 0. And if we replace 1 will be 1 minus 1, also 0. So 0 over 0. Now what is the limit? The limit is equal the derivative of numerator. So the limit x approaches 1, the derivative of numerator is 12x minus the derivative of denominator 6, the derivative of radical x. See, radical x, the derivative really is 1 over 2 radical x. Why? Because radical x is x or half. So the derivative of half by 1 is half, and x, then half minus 1 will be negative half. And negative half, I mean 1 over 2, x power half. I mean 1 over 2 radical x. So I write it now direct. So this you can see this in the derivative here. Okay, this one. So 6 times what times 1 over what 2 radical x. Yani I can write it direct in this one. Can be written direct in this way. Okay, let's write it here. Okay, you write it 6 times 1 over 2 radical x. Yani mean 3 over radical x. And the derivative of the matter is 2x only. So equal to x1. Now we have here 12 minus x1 will be 6 over 2. That is mean 3. Because the x radical 1 is 1. 2 by 1 is 2. So the answer will be 9 over 2. 9 over 2, the answer. Another example. Another example. Let us define the limit. X approaches 2. I have here x squared plus 12. So it will be 4. See this one. That's because there will be 16. If I have minus 4 will be 0. And if I have now x squared minus 4 will be 0 equal to, see, now if I put 2, this one will be here radical of 4 plus 2, 12, because 16, so be 4. So this will be here 4. Minus 4, so will be equal to 0. Denominator 2 squared 4 minus 4, 0. So you have 0 over 0 also. 0 over 0 also. Now, the derivative of numerator over the derivative of denominator. What is the derivative of numerator now? So the limit for this one, limit x, the derivative of the numerator. See, I have now x squared plus 12 to the power what half. So the half, and I have x squared plus 12 to the power negative half. Now the derivative of the inside will be times 2x. Yeah, you mean the answer 2 will be out. So the x over radical, because negative half will be denominator. So you can write it in x squared plus 12. Okay, x squared plus again. So this is half, the first one. This one is half, and half times 1 half will be negative half. The derivative of the x squared is 2x. So to cancel, so then we have x over this one. Why? Oh, because you have here negative. This is the power negative half. Okay, negative half. Now, so will be x. Now the will be, we said here x over now radical x squared minus 12. But the derivative of 4 is 0. This one 0 over the x squared. Even no need to write 0. This one, no need. So it will be 2x equal to, now the limit, clear, this one will be limit of x approaches 2. I have here x over square root x squared plus 12 times 1 over 2x. So we can cancel this x with this x because this like 2x over 1, so it will be 1 over 2x. Or you can replace direct also. You can replace here direct. This is step, no problem. Also can be simplified. So it will be equal to, I have here 1 over, this will be 4 plus 12, 16. So this radical 16 times what times I have this one? 1 over 2. So then the answer is equal to 1 over, this is 4 by 2, it will be 1 over 8, the answer.